Hello friends, I am Professor Maitray Bhagat, faculty at GLS BBA, GLS University. Friends, in my last session of function, I discussed about function, domain, codomain and range of the function, and also discussed about equal functions. And we did some problems regarding these topics also. Now friends, in today's session, we are going to discuss about different type of functions, real functions, different type of real functions, along with the application of functions in the economics. So let's start the today's session. So friends, first of all, we are going to learn the different type of the functions. Here we are having the different kind of the functions. Out of them, the first is 1 function. Now, which function is called the 1? If I consider the two different values of variable x, and if I find their images are also the different, then I say that a given function is a 1 function. I think this is difficult to digest. Am I right? Right? So let's see the example, and through this example, let's learn 1 function. Friends, here I am giving the example. You can see f from a to b, fx is equal to 2x plus 1. The set A has the elements 1, 2, 3 and the set B has the elements 1, 2, 3 up to 10. Now let's see, why do we say this f is the 1 function? Let me take to the solution. So friends, here you can see that we are given f from a to b. The function is given by 2x plus 1. Set A has 3 elements 1, 2, 3 and B has the elements from 1, 2, 3 up to 10. Now, let us consider the sets A and B. A has 3 elements 1, 2, 3. B has the elements 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now here we are going to consider the different values of variable x from the domain A. First I take x is equal to 1 and I am putting in the given function. So we see that we are getting the corresponding value as 3. So I associate 1 with the 3. Now I take x is equal to 2 and putting in the function f. So I have the value 5. So I associate 2 with the 5. And now I put x is equal to 3 in the given function. So I get the corresponding value equal to 7. So I associate 3 with 7. So friends, here you see that the values of x are different. I say x is equal to 1 and x is equal to 2. Both these values of x are different. And look at their images. Their images are 3, 5, which are also different. So friends, here as the values of x are different, their images are also different. You could consider the another pair x is equal to 2 and x is equal to 3. You can take the another pair x is equal to 2 and x is equal to 3 and see their images. Their images are also the different. So if the values of x are different and their images are also different, then the function is said to be 1 function. Am I clear? Now let's see the next second type of the real function. The second type of the function is many-one function. Friends, in the many-one function, values of x are different. Values of x are different, but their images are same. Let me take this example. F from a to b, x square plus 1. A is equal to -1, 0, 1 and B as the elements 1, 2, 3, 4, 5. Let's see how it is many one function. We are given fx is equal to x square plus 1, set A -1, 0, 1, B as 1, 2, 3 up to 5, set A -1, 0, 1, set B as elements 1, 2, 3, 4, 5. I take the value of x equal to -1 from the set A, and if I am putting in the given function f, then I get the corresponding value 2. So I associate -1 with 2. Now I consider x is equal to 1 and putting in the function, I get the corresponding value also 2. So I can associate 1 with 2. So friends, here in this example you can see the values of x -1 and 1 both are different, but look at their images. Image are the same. So as values of x are different but the corresponding images are the same, then we say that the function is many one function. So I think with this example the concept of many one is clear to all. Now let me take the another type of the function. My next type of the function is onto function. Friends, in the last session I said that the range of the function is a subset of codomain. Range of the function is a subset of codomain. But sometimes we find that range and codomain are equal. And when we find codomain and range are equal, then we say given function is onto function. So let's take the example f from z to z, fx is equal to x minus 1. Let me show you how it is onto. Fx is equal to x plus 1, f from z to z. In this problem, codomain is z. Now friends, I will find the range of this function, and if I find it is also z, then I say that f is onto. So let's find out the range. You know how to find out the range, which was already discussed in the last session. We consider the different values of x from the domain, putting in the function, and we find corresponding image. In this problem, our domain is z. That is the set of integers. It is not possible to consider all the values of x because this set is an infinite set. So I consider some of the values from this set. Suppose I take -2, putting in the function, so I get corresponding value -1. Let's take x equal to -1, then corresponding value is 0. If I take 0, then I get corresponding value 1. If I consider 1, then I have the corresponding value 2. For x is equal to 2, we are having the corresponding value 3, and so on. Friends, we are knowing that the set of all possible images is called the range. So if I am going to write down the range of this function, so I say that it is -1, 0, 1, 2, 3 and so on. And this set is showing the set of integers z. So friends, here in this problem we find that range is z, codomain is also z. That is, the range of function is equal to codomain. and therefore we say that f is onto function. Am I clear, friends? Now let me take the next type of the function, the bijective function. So friends, when we find any function which is 1 1 and onto both, which is 1 1 and onto both, then the function is said to be bijective function. And the example of this bijective function is f from z to z, fx is equal to x minus 1, right? So here this function is both 1 1 and onto, therefore I can say that it is bijective function also. Let's see, how do we say it is bijective? So function is f from z to z, fx is equal to x minus 1. Let's check whether it is 1 1 or not. Domain and codomain both are equal to z. Suppose I take x is equal to minus 1 from the domain, and if I am putting in the given function x minus 1, so I have the corresponding value minus 2. So minus 1 is associated with minus 2. Suppose I take x is equal to 0, then I find the corresponding value equal to minus 1. If I take x is equal to 1, then I find corresponding value equal to 0. So friends, here you see that all x are different, and see their images, they are also the different, right? Therefore we say that this f is 1 1 function, right? Now for onto we know, we find codomain. Codomain is z. Now I will find the range. So for range, you see, we consider the different values of x from the domain. So you can see you are getting the corresponding values minus 2, minus 1, 0, 1, 2 and so on. If you consider, if you take different values of x from the domain, you are getting the corresponding values which are also the integer, that is, it gives the set of integers. So the range of this function is also the set of integers z, and as codomain and range are equal, we say that f is onto function. So this f is both 1 1 and onto, therefore I can say that f is bijective function. Am I clear, friends? Now we discuss the last type of the function, which is the constant function. Friends, constant function, that is, it is independent of the variable x. There is no effect on image for any value of x. Or in other words, I can say that the range of the function is a singleton set. Then function is called constant function. The example of this constant function is f from n to n, fx is equal to 3. See, we are given f from n to n, fx is equal to 3. If I want to check whether this function is a constant function or not, so I am going to find out its range. The set n, set of natural numbers 1, 2, 3 up to n so on. Suppose I take x is equal to 1, putting in the function. Now you see that the function is given by 3, that is, it is independent of x. So there is no effect of this x is equal to 1 on the function, so image is equal to 3. Now I take x is equal to 2. I get the same image 3. So for all the values of x, we are getting the image is equal to 3. So I write the range of this function is equal to 3. As this range is the singleton set, therefore I can say that f is the constant function. So if we want to check whether the function is constant function or not, so we find its range, and if we find its range is the singleton set, then I say that the function is constant function. So friends, these are the types of function. Which are the types of the function? First, one function. Second, many one function. Third, onto function. Fourth, bijective function. And last, fifth is constant function. Now friends, we are going to see real function. What is real function? A function whose domain and codomain are the set of real values. That is, f from R to R is called real function. Now we are going to see this different type of real functions. See, earlier I discussed types of function. Now we discuss types of real function. So you understand that in the given function, the domain and codomain both are equal to R. The first type of the real function is linear function. F from R to R, fx is equal to ax plus b is called linear function. So any function which we find in the standard form ax plus b, it is called linear function. You see the examples: 2x minus 3, 7 minus 5x, 4x. All these three examples where we find the function in the standard form ax plus b. Therefore, they are called linear function. If we plot the graph of linear function, then we find it is always a straight line, right? My next type of the real function is quadratic function. The standard form of this quadratic function is ax square plus bx plus c. The examples of these quadratic functions are 2x square minus 3x plus 5, 7x minus 5x square, and last 4x square. So all these are in the standard form ax square plus bx plus c. Therefore, they are called quadratic function. And the graph of this quadratic function is a parabola curve. Now, we are having the next type of the real function is polynomial function. The standard form of this polynomial function is a0 plus a1x plus a2x square and so on. Let's see some examples: 2x cube minus 3x square plus 5x minus 1, 5x square minus 7x plus 1, 4x minus 3. If you are looking the first example, 2x cube minus 3x square plus 5x minus 1. In this function, if you see the power of x, the maximum power of the x is 3. So I say that this is the polynomial of degree 3. In the next example, we find 5x square minus 7x plus 1. Earlier, we say it is quadratic function. Friends, remember one thing, quadratic function is also the polynomial. It is called the polynomial of degree 2. And in my last example, I find linear function 4x minus 3. Linear function is also a polynomial function. and we say it is a polynomial of degree 1. So linear function and quadratic functions are also the type of polynomials. Am I right? Now friends, next type of real function is rational function. The standard form is fx is equal to gx upon hx. So here we find the different type of the real functions in both numerator and denominator. You see the some examples. Fx is equal to x square minus 3x plus 1 divided by x minus 1. So in this rational function, in the numerator we are having quadratic function, and in denominator we are having the linear function. Second example, 2x minus 5 divided by 7 minus 9x. In this example, we are having linear function in both numerator and denominator. So any function which is given by gx upon hx, then it is said to be rational function. Then we are having the next type of real function as exponential function. The standard form of this exponential function is a raised to x, and some examples of this rational functions are 2 raised to x and 3 raised to minus x. They are called the exponential function. Now the last type of the real function is logarithmic function. F from r to r, fx is equal to log of the x. Friends, you all are familiar with the log table, right? So in the log table we are finding the different values. So these values are derived using this logarithmic function. Also you are aware about anti-logarithm, right? So in this anti-log table values, we find the values, right? These values are nothing but they are the values derived from the exponential function. Friends, here this exponential function and the logarithmic functions are inversely related to each other. Are you getting my point? Now friends, we see the different application of function in economics. Let's see these applications. Friends, you all are aware about the cost function. How do we get this total cost of any particular product? So friends, this total cost of the product is divided into the two parts, fixed cost and the variable cost. And by summing these two costs, we get the corresponding total cost. So total cost is a sum of fixed cost and the variable cost. If I am saying A is variable cost per unit and B is fixed cost, so I say that the total cost function is given by AX plus B. Total revenue, we are multiplying the number of units sold with the corresponding selling price, which gives us the total revenue function. So if I am saying P is selling price per unit and X are the number of units sold, so I am saying that total revenue is given by P into X. Now the profit and loss function. So when we are subtracting the total cost from the total revenue, we find corresponding total profit or loss. If this function of total profit or loss is giving the positive value, then I say that it is profit, and if this value is negative, then it is said to be loss. And now break-even point. What is break-even point? No profit, no loss situation. And when it is possible? If total cost and total revenue are equal. When total cost and total revenue are equal, this situation suggests break-even point. So let's learn this application through some problems. Let me take the first example. In this example, the fixed cost of commodity is rupees 1250. The variable cost is 99 rupees per unit and the selling price is rupees 190 per unit. Now, you are asked to find total cost function, total revenue function and break even point. Let's solve this example. So friends, here in this problem, we are given fixed cost 1250, the variable cost is given equal to 99 and the selling price is given equal to 190, right? Now friends, first let me define total cost function. So friends, we are knowing that total cost is a sum of variable costs and fixed cost. Variable cost is 99 rupees per unit. So we get corresponding variable cost 99x. Friends, here variable cost is depending on the number of the units. So we are multiplying this variable cost 99 rupees per unit with x number of units. The fixed cost is 1250. It is constant, right? So we are not multiplying with x, remember. So we are having the total cost function is equal to 99x plus 1250. Now I determine total revenue. Total revenue is a multiplication of selling price with number of units. As selling price is 190 per unit, total units are x, so 190 times x is the total revenue function. Now I determine break even point. So we know that total revenue and total cost are equal. Then we get corresponding break even point. So I am going to compare cost and revenue function. The cost function is 99x plus 1250 and total revenue function is 190 times x. Let me solve this equation. So I am getting 91 times x is equal to 1250. And friends, now if we find the value of x, then I find x is approximately 14 units. See friends, when you are solving this equation, you may find the value of x is a fraction 13.74, but we know that number of units are always the natural number. Therefore, we round up this value and we find the value of x as 14 units. So for this 14 units, we do not have any kind of the profit or loss. Therefore, it is said to be the break even point. Clear? Let me take one more example. In this example, you are given the total cost function as 500x square plus 2500x and plus 5000. Selling price is rupees 6000 per unit. And we determine total cost function, total revenue function along with break even point. So let's see the solution. Friends, here you are given the total cost function. 500x square plus 2500x plus 5000. Total cost function is provided to you, but we see that the total revenue function is not available. So let me find it. Selling price is given equal to 6000. So I say that the total revenue function is given by 6000 times x. Now I will find the break even point. So let me compare our total cost function and total revenue function, replace them. And now I am going to solve this equation. So I have $500x square minus 3500x plus 5000 is equal to 0. On the left hand side, in all the three terms, we find the common divisor 500 and right hand side is 0. So I ignore this common divisor 500. So this equation is now x square minus 7x plus 10 is equal to 0. Now friends, this is a problem of factorization, and you are knowing how to find the factors of this quadratic equation. So if we find the factors of this given equation x square minus 7x plus 10, I find two factors as x minus 2, x minus 5. So I get two solutions, x is equal to 2 or x is equal to 5. So friends, in this problem, we are having the two break-even points, x is 2 and x is equal to 5. Why do we find the two solutions in this particular problem? Because if you are looking our cost function, it is a quadratic function. As it is quadratic, therefore it has the two solutions. And if you see our previous problem, so in our previous problem, our cost function is the linear function, and linear function has always the one solution. So friends, here with this problem, I am ending this topic of function. Now from next session, I am taking the topic on limit of function. The limit of function is required to understand the differentiation. Without having the knowledge of limit, we can not find out the differentiation. Therefore, it is must to have the knowledge of limit of function, which we will discuss in our next session, friends. So goodbye to all and have a nice day.